video, I'm going to quickly walk you through how to solve an incomplete Anova table. And we do this just so that you get a sense of how Anova tables work. And so that's the main reason why you could think of these as maybe as little Sudokus that you're doing here for these particular solving of the particular tables. So for this, a quick reminder of our formulas here. So to get the MS, or what we call the mean square, okay, remember a mean square is just another name for variance. And that's why this is called analysis of variance. The formula for that is just the sum of squares divided by the degrees of freedom, okay? And then for the F value equals the mean squared between divided by the mean squared within. Okay, so think of that as we walk through this. So we're going to figure out here, all we're given is the sum of squares for the between treatments and the total sum of squares. You're probably looking at this as saying, how is it that I'm going to figure all of this out? The key for this is, remember, to always start with the degrees of freedom of figuring that out. And so up here, we have information that helps us figure out what the degrees of freedom are, right? So for the between treatments, the degrees of freedom are about the number of groups that exist. So there's 3 groups, there's 3 treatment groups. So remember, degrees of freedom is the number of groups minus 1. So for this, it's 3 minus 1 equals 2. So those are our degrees of freedom for that. Our total degrees of freedom are, in our sample size within each group, is 7. So 7 times 3 is 21. 21 minus 1 gives us 20. And then there's 2 ways of figuring out the within treatments. One is just that these 2 both have to add up to be 20, so we know in that way it has to be 18. The other way is we've got 3 groups, and there's 7 in each group, so we figure out the degrees of freedom within each group, and then we add all of those up. So 7 minus 1 is 6, and so note the degrees of freedom within each group would be 6. 6 times 3 is 18, so we get the same answer. Either way is going to give you the same answer for that. Okay, so then we figure things out. Okay, we've got to figure out the mean square for the between treatments. We've got 120 divided by 2, and that gives us 60, right? Because here was our formula down here. Sum of squares divided by degrees of freedom gave us 60, so we got our mean square there. We have the information here, right? So for the total, 160 divided by 20, so that would give us 80. Here, how do we figure out this sum of squares? Well, remember, these 2 sum of squares have to add up to be the total. Okay, so 120 plus 40 is what would give us 160, right? Or the other way to figure it out is just 160 minus 120. Okay, that equals 40. And then, so our mean square here is 40 divided by 18. I got to get my calculator out for that. So 40 divided by 18. And so 2.22 that we have there. And then our F ratio, how do we get that? Remember that F is just the mean square between divided by the mean square within. So here's our mean square between, divide by our mean square within. Looks like we'll need a calculator for this one as well. So 60 divided by 2.22, and that gives us 27.03 if we're rounding. 27.03. Now, in solving these problems, we're not asking you to say, is this a statistically significant difference or not? Although an F value this large would always be statistically significant no matter what. That's a very large F value. So hopefully that helps you with your assignment here for solving in a one-way ANOVA table.